All right, so today we are going to be looking at lesson 3-3, and we are going to be adding and subtracting radicals. So when radical expressions have the same index and the same radicand, they are called like radicals. So for example, the cube root of 7 and the, I don't know why I just put the fifth root. I meant to put a 5. And 5 times the cube root of 7 are like terms. So since they have the same index and the same radicand, it's like having 1 cube root of 7 and 5 cube roots of 7. So if I were to add those, 1 and 5 is 6 cube roots of 7. So when you add and subtract these, the cube root of 7, the index and its radicand, kind of act like it would if it were a variable. If I replace this with a variable x and I just had 1x and 5x, you'd have 6x's. So adding and subtracting radicals is completely different than multiplying and dividing them. But adding and subtracting radicals is no different than adding and subtracting variable terms. They're pretty much identical. So here's a warning. You cannot take the square root of a, which has a different radicand, they both have the same index, and add the square root of b, and you cannot, take those and put them underneath the same radical and add them together. It's not like, you could do that with multiplication, but you cannot do that with addition. For example, what if I had the square root of 16 and I added to that the square root of 25? So currently the square root of 16 is 4 and the square root of 25 is 5. So 4 plus 5 is 9. So the square root of 16 plus the square root of 25 should come out to be 9. So what you can't do is put 16 plus 25 underneath the radical and expect that to come out to be 9. 16 and 25 is 41, and the square root of 41 is not 9. In fact, 41 is prime. So that does not equal. In fact, you might want to write here square root of 41 does not equal 9. So that's why you can't put them together. You're just not going to get something that's equal. So for combining radical expressions, you've got basically, if you have some number in front of here, if there's not a number in front, then it's assumed to be 1. So if you've got the same indexes and the same radicand, then all you do is take this coefficient, if you want to call it that, plus this coefficient, and just add those together. The radical string will not change. So for instance, this would become a plus b, and then the nth root of x, whatever that is. And same thing for subtraction. You would end up with a minus b times the nth root of x. So let's look to see how that works with some real problems. So let me make these really big. And let's look at some of these. So do they have the same index? Yes. Do they have the same radicand? Yes. So I have 5 of these and 3 of these. That means I'm just going to take 5 plus 3 is 8 of those. So the radical string is not going to change. So I end up with 8 square root of 2x. All right, look at B. So with subtraction, the same thing. I've got the same index and the same radicand, so I just have to subtract the numbers in front. So 8 minus 2, so 8 of these minus 2 of these is going to give me 6 cube roots of 5. And so that's your answer. So essentially, if you replace this with a y and you had 8y, So I'll just briefly do that and then I'll erase it. So if I had 8y, y being instead of the cube root of 5, minus 2y, 8y minus 2y is 6y. So y is the cube root of 5. It's the same thing. So I'm going to erase that just so that you don't wonder where it came from. All right, so then what I want you to do is pause the video, and then I want you to figure out C and D on your own and then restart the video. Okay, so this time I've got, again, the same index and radicand, so I'm just going to take 4x's and subtract 9x's. And so that's going to give me negative 5x's times the square root of xy. And then for D, I've got 17 minus 11, which is 6. So that's going to give me 6 fifth root of 3x squared. All right, so for example 2, it's a little bitty word problem. And at first glance, it might be a little confusing, but really think your way through it. The design of a pathway uses the pieces shaped as squares with side length of 15 inches. Find the length of the path. Well, there's some important information here. Important thing number 1, the pieces are shaped as squares. So from your geometry days, you should know quite a few things about squares. And then the other piece of information is that the side length is 15 inches. So that means that this is 15 inches here, this is 15 inches here, and there's a right angle here, and actually all the way around there. So we are looking for the length of the path. So that length of the path is all the way through the diagonals of these squares. I can kind of view it that way if I so desire. And the reason why it's important to view it that way, I'm going to redraw this triangle here, right here, and let's use some of our geometry. So if my triangle looks like this, I have a right angle here, and then this is, this value right here, let's call it x. So this is my x. And then that means that this is my 15 inches, and it is inches, right? Yep. And then this is my 15 inches. And then inches. Okay. So wouldn't we use Pythagoras' theorem to find x? So a squared minus b squared equals c squared. So this is going to be step 1. And so my a and my b are my 15. So 15 squared and 15 squared. So we're going to subtract those, or add those. I don't know why I put a minus there. We're adding those, is equal to c squared. So we end up with 225 for each of those. So we're going to add 225 to itself, and we get 450. So then we need to simplify 450. So I'm going to find both the exact answer and I'm going to find the decimal answer using my calculator. But first, in order to solve for C, I have to take the square root of both sides. And then I'm going to prime factor 450. Well, 450 is 45 times 10, and then the 10 is a 2 and a 5, and the 45 is 2 3s and a 5. So C is equal to the square root of a 2, 2 3s, and 2 5s. All right, so I want to take a pair of 3s, so a 3 is going to come out in front, times, and a pair of 5s, and the 5 is going to come out in front, so C equals, and then left underneath the radical is 2. So I end up with 15 square root of 2 inches for the diagonal of that square. Well, that's only the distance from here to here. I've got 1, 2, 3, 4, 5, 6 diagonals. So I need to take this 15 rad 2 and I need to multiply it by 6. And so I end up with a final answer of 90 square root of 2 inches. So the length is equal to 90 point square 2 inches. And so, of course, you would write that in a sentence. Therefore, the length of the path is 90 radical 2 inches. Now, if I walked into Home Depot and said I need 90 radical 2 inches worth of tile, they're going to look at me like I'm crazy. So plug that into your calculator, and it will turn out to be approximately 127.28 inches. And for every 12 inches, it's a foot. So if you divide that by 12, you are going to get approximately 10.61 feet. So these and these conceivably could be your answers. All right, so let's look at some more complicated adding and subtracting of fractions. So again, remember, to add and subtract fractions, we have to have like radicals. So right now, none of these radicands underneath are the same. So what I'm going to do is prime factor each of these numbers and simplify each of the fractions, and hopefully I'll have 2 or all 3 of them with the same radicand so that I could combine them. So I'm going to go ahead and prime factor 250. So I get 25 times 10, and I don't know why I'm writing that. Let's try that again. 5 and 5, and 2 and 5. So I end up with the cube root of 2 and 3/5. Then with the 54, that factors as 6 times 9, and then I have a 2 and a 3, and 2 3s. So I get plus the cube root of a 2 and 3 3s. And then minus the 16 you're going to start to discover is 4 2s. So if you prime factor 16, you should have 4 2s. All right, so then I'm looking for groups of 3 because my index is 3. So I'm going to pull a 5 out in front here. So I have a 5. And then I end up with the cube root of 2. Then I'm going to pull out a group of 3's here. So I have plus, I got a 3 out in front, and then I'm left with a 2 underneath, so a cube root of 2. So far those are like radicals. Then I have minus. I'm going to pull out a group of 3 2's. So 2 comes out in front, and whoa, lo and behold, another cube root of 2. So all 3 of my radicals are the same, so I'm just going to look at the coefficients. 5 plus 3 is 8. 8 minus 2 is 6. So this equals 6 cube root of 2. And that, my friends, is my final answer. All right, so I would like you to pause the video, and I want you to prime factor 20. Oh, and just as an aside, when you prime factor the 20, whatever you pull out in front as a square root has to get multiplied to the 6. Same thing here. When you prime factor the 125, Whatever you pull out as a perfect square has to get multiplied to the -3. So pause the video and then look to see if, and do both B and C, and look to see if your answers are correct. Pause it. Okay. So I'm going to prime factor 20. And so when you prime factor 20, you get 6 out in front. And I get 2 times 5. And then -3. And then I get 5 3s underneath here. So I'm looking for pairs, groups of 2. So I have my 6. And I'm going to multiply the 2 that I'm bringing out in front to the 6. And then I have a 5 left underneath. Then -3. I'm going to bring out a pair of 5s as a 5. And then I have a square root of 5 underneath. So then you got to multiply the 6 and the 2 together and the 3 and the 5 together. So I have 12 radical 5 minus 15 radical 5. Now you have like radicals, so you're just going to subtract the coefficients. So 12 minus 15 is a -3 square root of 5. Done. All right, what do we do with the variable? Don't forget your index rule. So I'm going to prime factor 18 and 50, and I have -3 square root, and I have a 2 and 2 3s along with an x squared, plus 2 square root of a 2 and 2 5s and an x squared. So we have a -3. I want to find groups of 2, so I'm pulling out a 3, so times 3. And then I'm going to use my index rule and divide that by 2. So 2 goes in there evenly once, so I get x to the first out in front. And then left underneath the square root is just a 2. All right, then on the second one, I have plus 2. I want to take out a group of 2, so that 5 comes out in front. And then again, divide by 2, and so you get x to the first out in front. And you are left with just a 2 underneath. So then multiply everything that's in front separately. So we get -9x square root of 2 plus 10x square root of 2. Finally, I have like radicals, and then I have like coefficients because since there's an x out in front, they both have to have the same variable string, which they do. So I've got a -9 and a +10 gives me a +1x radical 2. And technically you can put absolute value signs around that x. And so let's go ahead and do that to stay consistent. All right, so let's go ahead and square some binomials. This is going to become important as we rationalize a denominator that has addition or subtraction signs in it. So what I want you to do is look at example 4, and this should be example 5 down here. I don't know why mine says a 4. Yours might say a 5, but this should be example 5. So I want you to look at example 4 and example 5, and I want you to see what kind of problems do the radicals disappear. Because remember, if any of these happen to be in the denominator of a fraction, we're going to need to rationalize the denominator. We haven't talked about how you rationalize the denominator if there's addition or subtraction signs with a radical. So to find the product, we're going to FOIL these binomials. And when you multiply, so I'm going to multiply the 3 to the 2 and the 3 to the 4 radical 5, and then I'm going to multiply the 2 radical 5 to the 2 and to the 4 radical 5. So you've got 4 products going on here. You have to multiply what's outside of a radical to what's outside and what's inside to what's inside. So 3 times 2 is easy. So that one is 6. And then I've got 3 times 4 radical 5. Well, the 3 is outside and the 4 is outside, so I can only multiply the 3 to the 4, and then we'll tack on the 5. It's no different than multiplying 3 times 4x. You'd have 12x. So 3 times 4 rad 5, you've got 12 rad 5. So let's write that down. So positive 12 rad 5. And then 2 rad 5 times 2. 2 times 2, those are what's outside, so that becomes 4 rad 5. And it is a like term to this one, so I'm going to line them up. And then finally, I've got the 2 and the 4. So 2 times 4 is 8. So I got a positive 8. And then remember, radical 5 times radical 5 is just 5, because a radical times itself is the number under the radical. But you have to multiply it to the 8, because we've got 2 times 4 is the 8, and then rad 5 times rad 5 is 5. And remember, these are all being multiplied together. So now we can collect like terms. So I get a 6. These are now like terms, so I'm changing my rule. I'm adding like terms, so all I do is focus on the coefficients. 12 plus 4 is 16. Radical 5s plus 8 times 5 is 40. And so our final answer is going to be the 6 and the 40 is 46 plus 16 radical 5. And there you have it. Now notice that we still have a radical in the answer, so that wasn't the problem I was looking for. Then you go ahead and pause the video, and I want you to multiply b and c, but don't forget that, remember, c, you can't just square the radical 2 and square the 5. There's a middle term, so you have to write it out the long way. Radical 2 plus 5 times radical 2 plus 5. You should have 4 products on that one. So pause the video and find those products. Okay, so 5 times 4 is 20. And 5 times radical 3, negative radical 3, is going to be negative 5 radical 3. Then radical 3 times 4 is positive 4 radical 3. And positive radical 3 times negative radical 3 is a negative 3. So you get 20. A negative 5 and a 4 is negative 1 radical 3, and then minus 3 equals, you can still add the 20 and the minus 3, so you get 17 minus the square root of 3. Then for C, we've got radical 2 times radical 2, which is 2. And then radical 2 times 5, which is positive 5 radical 2. Then 5 times rad 2, which is positive 5 radical 2. See, those are not going to cancel each other out. And then finally, 5 times 5, which is 25. You end up with 2 plus 10 radical 2 plus 25. The 2 and the 25 is 27 plus 10 radical 2. And that's it. That's your answer. All right, so let's look at example 5, because nothing in example 4 got rid of the radical. They all had the radical. So I'm going to make these bigger. Okay. So let's go ahead and FOIL this, and let's see what happens. So I have 6 times 6, 36. 6 times radical 12, positive 6, radical 12. Then negative radical 12 times 6, so that's a negative 6, radical 12. And finally, a negative times a positive is a negative. Rad 12 times rad 12 is just 12. So notice that these cancel, and you are left with 36 minus 12, which is 24. Notice that for once, we actually got rid of the radical. So let's do another one, B. I want you to try B on your own. So pause the video, tell me what you get, and do C on your own too. All right, so let's go ahead and look at these. So if I FOIL, I get 3 times 3 is 9. 3 times negative radical 8 is negative 3 radical 8. Radical 8 times 3 is positive 3 radical 8. Those are going to cancel. And then a positive times a negative is a negative. Rad 8 times rad 8 is 8. So these cancel and you get 9 minus 8, which is 1. So again, our radicals cancel. Last one is this one, a little bit more complicated. Remember, you multiply what's outside of a radical to what's outside and what's inside to what's inside. So 4 times 4 is 16 times radical 6 times radical 6 is 6. 4 times negative 5 is negative 20. Tack on the radical 6. Then same thing here, 5 times 4 is positive 20, but tack on the radical 6. And finally, positive times negative is a negative. 5 times 5 is 25. So we end up with 16 times 6, which is 96. These cancel because they're opposite signs, then minus 25. And that gives us 71. So again, the radicals canceled. So what do you notice about these binomials versus these binomials? Well, hopefully you realize that you have this plus minus pattern going on here. Another plus minus pattern. And another plus minus pattern with the same thing here and the same thing here. Isn't this a difference of two squares factor pattern? So the difference of two squares factor pattern can help us get rid of a radical in the denominator. So when we look at your last page of notes, we're going to rationalize a denominator that has addition and subtraction in it. All right, so these are the last 3 problems. And they tend to be a little bit of a doozy until you get used to them. So remember that that difference of two squares factor pattern is going to help us get rid of this radical in the denominator. So I cannot multiply this denominator by the square root of 6. If I try to multiply this denominator by the square root of 6 and I distribute that in here, well, radical 6 times radical 6 is 6. You'd still have a minus there. But when you distribute it here, the 3 is outside the radical and the 6 is under the radical. So it would become 3 radical 6. That does not get rid of the radical. So we cannot multiply by just a radical 6. So instead, we learned in our last example that we could multiply by the difference of two squares factor pattern. So I'm still going to have a 3 and a radical 6, but instead of a minus sign, I want a plus sign. So we want this plus minus pattern. What you do to the bottom, you have to do to the top. So I have to multiply the top by 3 plus the square root of 6. So then let's distribute. So in the numerator, I get 4x times 3, which is 12x. And then 4x times radical 6, I get positive 4x radical 6. These are not like terms. I know that these are both x's, but that has a radical 6 attached to it. That does not, so you cannot combine these. So we are over. And then I am going to do it the long way the first time, and I'm going to show you the shortcut. So 3 times 3 is 9. And then 3 times radical 6 is positive 3 radical 6. Then negative 6, or negative radical 6 times 3 is negative 3 radical 6. And then finally, negative rad 6 times rad 6 is a negative 6. So remember that the positive 3 rad 6 and negative 3 rad 6 cancel out, and you end up with 9 minus 6, which we get 12x plus 4x radical 6, all divided by 9 minus 6, which is 3. So we no longer have a radical in the denominator. So this is our final answer. Now, for the shortcut, couldn't we just, if we know we have a plus minus pattern, couldn't we ignore the fact that we have this, and couldn't we just square the first term? 3 times 3 is 9. Square the last term, rad 6 times rad 6 is 6, and just put a minus in between. The difference of 2 squares. So if you see that pattern, go ahead and use it. If you're like, huh? Then go ahead and follow it the long way. Just make sure that your inner and outer terms cancel. All right, so what I would like you to do is pause the video, and I want you to do B and C. Now I know that B has 2 radicals in it, but you're still looking for the plus minus pattern. So when you rationalize this denominator, you're going to use exactly the same things here, the rad 3 and the rad 5, but the thing you're changing is a plus sign to a minus sign. So go ahead and multiply the top and the bottom by radical 3 minus 5. So pause the video, do B, finish B, and do C. Okay, so I'm going to go ahead and distribute. So multiply what's outside of a radical to what's outside. So I've got the 2 to basically a 1 outside here. So 2 times 1 is 2. Rad 7 times rad 3, 7 times 3 is 21. And then I've got radical, or 2 times basically a negative 1. So I get a negative 2. And then 7 times 5 underneath that radical is a square root of 35. So we do not have like radicals, so I cannot combine those. And then over, I'm going to apply the shortcut. So remember, if this is the difference of 2 squares factor pattern, this is a plus b times a minus b. That's supposed to equal a squared minus b squared. This is a, that's b. So the radical 3 squared is going to be 3 minus the radical 5 squared is 5. So I end up with 2 square root of 21 minus 2 square root of 35, all divided by a negative 2. Now it might seem as if we're done, but technically we're not, because please note that this and this and this, all 3 of these have a 2 in common. So I can divide each one of them by 2, and in fact I'm going to factor out a 2. Can't I factor a 2 out from here and from here? And so I'm going to prove to you that they are reducible. So if I factor a 2 out from the numerator and divide each of these by 2 and by 2, note that you get square root of 21 minus square root of 35, all divided by negative 2. So 2 divides into 2 once, and 2 divides into negative 2 negative 1 times. So now I have a square root of 21 minus the square root of 35 all over negative 1. Well, we don't write things over 1. So we're going to have to divide each one of these by negative 1. So you get negative square root of 21 and a positive square root of 35. If that bothers you to have the negative square root of 21 first, then you can put the positive square root of 35 first. It doesn't matter which. But there's your answer to B. Now for C, to rationalize this denominator, you have to multiply by the difference of 2 squares pattern. So it has to be 1 plus the square root of 2 times 1 plus the square root of 2. So make sure, because you've got a binomial times a binomial. So we've got 1 times 1, which is 1. And then 1 times rad 2, which is positive rad 2. And rad 2 times 1, which is another positive rad 2. And then finally, rad 2 times rad 2, which is a positive 2. All divided by our difference of two squares factor pattern, this plus minus pattern. So then I'm just going to do a squared minus b squared. So 1 squared is 1. And then minus radical 2 squared. Radical 2 times radical 2 is 2. So again, and this doesn't normally happen that you have a negative 1 in the denominator all the time. It's just a coinkydink. So the numerator becomes 1. Please note that these do not cancel each other out. You have one of these and one of these. So we end up with 2 rad 2's and then plus 2 all over negative 1. So the 1 and the 2 combine and you get 3 plus 2 radical 2 all divided by negative 1. And of course we have to divide the negative 1 here and here, which changes both signs. So our final answer is negative 3 minus 2 rad 2. And that is the end of this lesson. So good luck on your homework. If you have any questions, feel free to text me.